Okay, problem number 26 in group theory. List the finite groups that contain at most two conjugacy classes. Okay, so the solution is going to be the finite groups that contain at most two conjugacy classes will be, it's going to be the trivial group, and it's going to be z mod 2. Z mod 2z. Okay, and we'll demonstrate this. So if G has only one conjugacy class, then every element is conjugate. Every element is conjugate with the identity, since if G is in G, then G inverse equals that. For all G in G, we have that every element will be equal to the identity. So if every element is conjugate with the identity, then every element is equal to the identity. Therefore, G is equal to the G is just equal to the trivial group. And the trivial group is the one conjugacy class. Okay. If G has two conjugacy classes, then the trivial group will be one of them, and let C be the other. Okay. So then we have that G is equal to, well, the trivial group disjoint union. G is the disjoint union of the trivial group and C. Okay. Thus, this is backwards. The order of C is equal to the order of G minus 1, because G is equal to C unioned with just one element, the identity. So the order of C is equal to, whatever G is minus 1. Okay. Actually, before that, we're going to pick an element in C. Then by the orbit stabilizer theorem for conjugation, or orbit stabilizer theorem for conjugation, we have that the order of C is equal to the index of G and the centralizer of X. So, okay, we know that the order of C is the order of G minus 1, so maybe we'll let n equal the order of G. Then, okay, so if n is the order of G, we know that this piece is equal to n minus 1, and it's also, by definition of index, because G is a finite group, it's equal to n over the order, n over the order of the centralizer. Okay, and if we solve for the order of the centralizer of X, we would get the fraction n over n minus 1. Okay. And we know that order is an integer. We know that this fraction n over n minus 1 is a positive integer. Thus, n minus 1 has to divide the denominator has to divide the numerator for it to be an integer, a positive integer. Okay. Further, we know that n minus 1 divides itself. So since 1 is equal to, well, it's n minus 1. So 1 is equal to n, which we know n minus 1 divides n, minus n minus 1. Of course, n minus 1 divides itself. So 1 is equal to two things that both divide n minus 1. So since 1 equals this, we have that n minus 1 divides 1, and it's a positive number. Therefore, n minus 1 is equal to 1. So n equals 2. This gives us that the order of G is equal to 2. Therefore, G is equal to Z mod 2Z, or I'll even say isomorphic here. And we are finished with 26.